This is Bharat. Welcome to my channel. Now we are going to be discuss about the digital electronics. Like first of all, what is digital electronics? Means it is going to be deal with zeros and one. It is going to be deal with zeros and one. So that is nothing digital electronics. So nowadays in all the like mobile applications, everything computers which will run on the only these values zeros and 1. Now we are going to be see what under different things will be there and how it is going to be deployment in that digital electronics. Now we have number system, like we have different types of number system. For example, I need, like I went to some shop, I am going to be asked how much you need. So for example, if I don't have any number system, how I can able to ask them? So we have some confusion, like I want this much, I want this much, means we can't able to take how much, means they can't able to get that thing. So by using this number system, like we have different types of number system like decimal, binary, hexadecimal and octal. So decimal is nothing but this radix, base is nothing but this base is like 10. Okay, binary is nothing but 0 and 1. This radix, we can call this is a radix or base. Okay, this base, okay, radix 10, this is 2. Okay, this is hexadecimal is 16, octal is 8. Okay, 0 to 7 we can able to represent the numbers here, 0 to 15, but 0 to 9 is the numbers, and from 10 onwards we are going to be represent 10 is nothing but A, 11 is nothing but B, 12 is nothing but C, 13 is nothing but D, 14 is nothing but E, 15 is nothing but F. So in this way we are going to be discuss the things. Okay, so we have deal with this binary number system, like how we can able to convert from decimal to binary. Okay, we can convert decimal to binary. For example, how we can able to convert? For example, we know, so this is decimal 100 you can say. Okay, this is like what place value. Okay, this is ones place, this is tens place, this is 100 place. Okay, like this we can able to told. Now here what going to be happen means, for example, this is base 10, so you can say base 10 power 0 ones place into 0 place, 10 power 1 into 0 place, 10 power 2 into 1. So now we can able to 10 power 0 is nothing 1 into 0 0, 10 power 1 into 0 only, 10 square is nothing but 100, we will get 100. Same like that we have for a different, like we can say binary. So if you are taking a binary number like 1 1 1, this is 5 in decimal, I need this is in place value. So this is base is 2 radix, so n power 0 into 1 plus n power 1 into 1 plus n power 2 into 1, like this we have to do. Here base is nothing but here n, so 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1. So what going to be happen? So like this we are going to be get. Here n power 0, n power 1, n power 2, like this we are going to be get the different things. You can observe over here. Okay, here 2 power 0, 2 power 1, 2 power 2 into 1 equals to, so we will get 5 over here. Okay, so that is the thing. Now we are going to be discuss about the like how we are going to be convert in one number system to another number system. We have seen, like if it is binary means this is like this we need to calculate. If I need to convert into what, binary to decimal, same like this only we have to convert. Okay, decimal. For example, any number has been 101, so what is the, if you need to convert it to decimal means, so how I can able to convert 2 power 0, 2 power 1, 2 power 2. Okay, 2 power 0 into 1 plus 2 power 1 into 0 plus 2 power 2 into 1. So now what going to happen? 2 power 0 into 1 is nothing but 1 only, na 2 power 1 into 0, 0 only, 2 square 4, so we will get 5. This is the value of 5. Okay, 101 is nothing but 5. I told a mistake. 1 is nothing but 7. Okay, here you can observe that this is 7. Okay, this is 7. I forgot to mistake. So this is the value thing 7. Now what going to be happen? We have like Boolean theorems. Okay, I will tell the introduction now. Boolean theorems. So in Boolean theorems, what going to be happen? Na? Like what we have these theorems. How these theorems will help means, for example, if we have Boolean expression like this, a b c bar plus a bar c plus a b c, like this we are having. Now what how many gates I need? 3 input AND gate I need, and 1 NOT gate I need. Okay, for to implement this one. Okay, after second to implement this thing, how many gates is needed? 3 input AND gate is needed, 1 NOT gate is needed. For this, how many? 3 input AND gate is needed, and to combine all these things, 1 OR gate is needed for me. Now what I have to do means, this is 3 input AND gate. Now what going to be happen? So if it is like this means a b c bar plus a b bar c plus a b c, I can able to simplify by using some Boolean theorem. So for example, here you can observe that from this I can able to take common a b. Okay, c plus c bar will remain, a b bar c. Now what going to happen? A b into 1 plus a b bar c has came. Now again we can take common a over here. So b plus b bar c. Now what going to happen? AB plus AC came. So how many gates is required here? 2 input, 2 AND gates, 2 AND gates and 1 OR gate. OR gate is required to implement this. So how many gates? 3 input, 1, 2, 3 and 4, 5, 6 gates is required over here. Now after deducing by using some Boolean theorems, we can able to reduce this to AB plus AC. So how much it has been reduced means, like we can observe that 1, 2. So we can able to two NOT gates. Here how many gates means 3 input AND gate. Okay, 3 input AND gate, 3 input AND gate, 3 input AND gate is required, and 1 NOT gate. For B, 1 NOT gate. Okay, now so see here how many gates is required over here. Okay, and 1 3 input OR gate is required. Same operation, if we are applying some inputs, we will get some output. Okay, that is this and all combinational circuit. If you are giving some inputs, it is going to be produce output. It depends upon the present input only. If you apply some inputs, you will get some output. Okay, that is nothing but combinational circuit. If for example here same circuit, if you are applying same inputs, you are getting the same output by using this functionality also. So AB plus AC. So here see how many 3 gates only required, 1 2 3. Here 1 2 3 4 5 6 gates is required to place this thing. For example, now I need to do to place that and all gates, I am going to place 6 gates. Okay, 6 gates over here in this manner. Now I want to place only 3 gates. Here you can observe now we have implemented this 3 gates over here. So here we are going to place 3 gates only. So now what going to be happen? How much space it has been reduced? See here, see this much space has been reduced. Okay, so and now what and all by using these theorems we can able to simplify the circuits. And what going to be happen second means, like propagation delay. For example, from input to output, so from here to here it has to go, from here to here it has to go, from here it will have some delays, like we have some delay 1 nanosecond, 1 nanosecond, like that some delays will be there, which is we cannot able to say based on that gate we have been used. They have fixed delays will be there for gate. So based on that, okay, so here 3 gates only we have used. Delay will be reduced, propagation delay we can say delay reduced, and space space also be reduced, okay, and delay has been reduced. We can simplify the circuit and the number of the wires get be reduced, because we need to connect those things, we need some wires, that wires also has been reduced. So these are some of the advantages, like by using these Boolean theorems we can able to simplify the expression, okay. So this and all Boolean theorems, we can see about the important Boolean theorems now, okay. So now what and all Boolean theorems we need to see means, just see over here. So r r law anamata. So what going to happen, a plus a, any term, for example one or gate, if we are giving some input a, we will get a only, okay. If we are giving a plus a bar, what going to be happen, a means 1 1, so we will get 1 only now. R gate, a plus r is nothing but just like addition, okay, just adding of that. 1 plus 0 we will get 1, anything 1 plus anything whatever it may be, because this is R gate. If one of the input is 1 means exactly the output going to be 1. I don't want to check other inputs, it is going to be 1 only. So that is nothing but, for example a plus a plus a plus, we will get a only, a bar plus a plus abc plus whatever it may be. So what going to be happen, we are getting a plus a bar, what going to happen, 1. So 1 plus anything, what going to happen, 1 only, okay. That is the thing, okay. So now what I have to do means, just I am going to be discuss about the AND law. AND law is nothing but just multiplication. We have this AND gate. This property of this AND gate is nothing but, whenever we are giving 0 0, output will be 0 defaultly. For example, I don't want, if one of the input is 0, the output going to be 0 only, okay. That is nothing but AND anamata, okay. So now what going to be happen, 0 0, we are giving 0 only output, okay. That is nothing but AND law. Now 0 into 0, 0 only, 0 into 1, 0, 0 into 1 into 0, 0 only, 1 into 1 is nothing but 1. So whenever this input, whenever all the inputs of the wire it is going to be 1 means, then only output we will get 1. That is nothing but AND law. These are basic gates. What are these basic gates is nothing but AND, OR and NOT. These are basic gates, okay. By using these gates, why we are calling these are basic gates means, we can able to implement any digital circuit by using these basic gates. So that's why we are saying this is nothing but basic gates, okay. This and all basic gates. Now after doing these basic gates, we have arithmetic gates. Arithmetic gates is nothing but XOR and XNOR. This and all nothing but arithmetic gates, okay. So XOR is nothing but odd one detector. It will detect the number of ones. If it is, for example, 101, take, okay. This is odd one detector or not. It will take, if it is 1 means, okay, we can observe that, okay, this have odd number of ones, okay. If it is 0 means, we can observe that it having some even number of ones, like that, okay. That is nothing but arithmetic gates. Now we have NAND and NOR. These and all universal gates, okay. Universal gates is nothing but, what going to happen now, we have NAND and NOR. By using NAND and NOR, for example we have NAND and NOR we are using. So NAND is nothing but, we can able to implement any digital circuit by using basic gates. We can able to implement, for example if you am not having those gates, then how I can able to implement, by using these universal gates we can able to implement any digital circuit. So that's why this and all called universal gates. Not only this thing is universal gate, for example any of the gate, for example like this is there, okay, one AND gate is there with me. Now what I have to, I need to implement some gate A B bar is there. I need to implement A B from this gate. How I can able to implement A B bar? So I will give another input, okay. So like this. Now what going to happen, 1 will come over here, B I am giving as an input over here, So B bar we will get, this B bar will go and again it will comes B and we will get AB. So you can observe you will get AB. So but what the gate is AB bar, okay, but you will get any of the thing by using these things, okay. But majorly we have NAND and NOR are called universal gates. Not only those gates are called universal gate, but we can also say this is also an universal gate. Why means we are implementing another gate from those this gate. So that's why we are telling this also may be an universal gate. Like we are able to implementing any digital circuits now, then we can able to see this is nothing but universal gates. Remaining part tomorrow we can see.